Hi, welcome to the first video of making a programming language with JavaScript. Now this repo is a JavaScript port of Bob Nystrom's amazing book, Crafting Interpreters. Definitely recommend checking out, and I'll link to it in the description below. So in this video series, we're going to use JavaScript to make a programming language called Lox. And Lox is the syntax from the C family, so it's going to look familiar if you know C, Java, JavaScript. It's also a dynamically typed language. Let's take a look at some examples of what Lox looks like. So you have this print hello world. Looks a bit different from JavaScript in that there's no parentheses here. And then we have some quality operators and things like that. We have a variable instantiation here. If else control flow. We have a for loop here. And then functions are defined with fun. Some more functions here. And functions are first class in that you can pass a function as argument here. And we have a class here as well. So this is what the Lox language looks like. And if you want to run Lox, you can do so via the REPL or from a file. To run it via the REPL, just call node and then main.js without anything. If you want to run it from a file, just call your file.logs as the argument here. So at the end of the series, we're going to make a programming language using JavaScript that can do all of this. And in this first part of the video, we're going to make a scanner. So what that means is that we're going to be able to scan everything that we pass in, and then each thing is going to be parsed as a token. For example, we'll recognize this fun as a function declaration, but recognize this print as a function call. Or if we're passing this, we're going to recognize that a var is going to be a keyword, and this average is going to be the name of a variable, equal sign here, and then the values of our variable here. And this will be a string, numbers, and things like that. So this first part, we're going to output a scanner. And I'm just going to show you what that looks like here. So right now, we're in the REPL. For example, we call 5, it's going to say, okay, this is a token number, and the Luxem literal 5, and then it's going to hit the end of file. If we hit the string hello world, there we go. We have recognized that this whole thing is a string, and it's hello world. What if we do var hello goes to world, and there we go. Recognize that this is the var keyword, and then the hello is not a string though; it's an ID, it's an identifier. We have the equal sign, we have the string world, the semicolon here, and then the end of file. So in this video, we're going to make a scanner that can do all of this. All right. If you want to take a look at the end product, I'll show you in the, I'll link to it in the description, and you can run it from here. But in this video, we're going to code all this from scratch. So I'm going to have a new repo here, npm init. And in our package.json, I'm going to add type module. This lets us use the ESM style way of importing packages or files using import. All right. Then I'm going to create a source directory and our first file, Lox.js. Okay, so we created a file called Lox.js. First, we're going to do some imports that we're going to need later on, and I'll show you as we go through. And then it's going to import a scanner that we're going to code later. We're going to instantiate our Lox class. And then in our Lox class, we want to keep track of if there's any errors And we're going to instantiate head error to false first, but if there's going to be any errors later on, we're going to change that to true. And then our main function here is going to be finding the variables from args. And if there is a variable from args that's more, and the variable length is more than one, then that means there is an error because we expect at most one argument, and that's the script here. So this is how the file is called if there is a script node, and then actually it should be a main.js script. If there is a argument that you and the length is one, then we run file, passing in that file. Otherwise, we run prompt, and that passes, and then that lets us enter the repo that you saw earlier. Now we're going to need run file. So how run file works is that we're going to use a fs to grab the file data from source, which is the file name, and we're going to call this.run data. And if there's any error, we're going to exit. So this run file is basically just a wrapper over this.run, which we'll see later. And then next up, we have run prompt. So run prompt, we're going to create a reline interface, which is just a REPL that you saw. And then on every line, we're going to call this.run on that line. And if there's any error, even if this run has an error, we're going to reset that had error to false because we want the user to continue going through the REPL. And then we're going to keep on giving them the prompt, which is the sign here. And then both of these functions here, run file and run prompt, their main really just a wrapper around this.run. So how run works is that we're going to call our scanner, and then we're going to scan everything in source, which is either the whole file itself or each line. And then the scanner is going to return a set of tokens. And for each token, we're just going to console log it. So that's how run works. And just a couple of things that we do need for the programming language to look good is to have error reporting. So whenever there's an error, we're going to pass in what line that error was and the message. And then we're going to console the error that's that error with this message here. And then whenever there's a error, we're going to set this had error to true. And that's it for the Lox main function. Next, we're going to create a new file. It's going to be TokenType.js. In TokenType.js, I'm going to copy this over from what was on the GitHub repo. And so token type is basically just a dictionary of the different tokens. So if we see a left parentheses, we're going to match it with this. And then left brace, right brace, comma, dot, minus, plus, semicolon. So these are our single character tokens. And then we have two character tokens, one or two characters, the bangs, the equals, the greater, less than. And then we have literals. So identify is not the string ID, but it's something like var, V-A-R. And then we have strings or numbers. These are literals. Then we have the important keywords. So and would not be the string and, but it would be some sort of logic like our variable hello is our variable, or maybe 5 is great. 5 is greater than 1 and 5 is greater than 2. So it's our logic like that. And we have important keywords like class, else, false, function declarations, super, this, var, true, wow. And then to end off everything, we have EOF, which means end of file. So these are all the tokens that we want to be able to recognize. Next, we're going to create another file called Token.js. Now, Token.js is basically just a class that holds the values of each token. And each token will have 4 attributes: the type, lexeme, literal, and the line. So token type is basically what is here. Is a single character? Is it something like left parentheses, or is it a string, a number, or is it a keyword? That's token type. And literal and lexeme we'll see later on, and then line will refer to what line that token was. And then we have a convenience method to string, which will just return all of these attributes in a string format. And that's what each token will look like. And then the final file we're making today is called Scanner.js. And this will be the where the core functionality is for our scanner. First, in our scanner, going to do some imports. We're going to require the token type, the token, and our Lox class. Okay, we'll make this class called scanner and do the export. And then we're going to, in our constructor, we're going to instantiate some things. So whenever we call scanner, we're passing in the source here. And you can see here when we've called new scanner passing in source, which is either a line in the REPL or the whole file that is from the script. And then we're going to keep track of some other things. So for each token we see in source, we're going to add that to the tokens array. And we're going to instantiate start as 0, current as 0, and these variables are going to be used for iterating through our source here. And the line will start at 1, of course. And our first method for a scanner is going to be called scan tokens. So you can see, if you recall here, scanner.scan tokens is the one that is called to get the tokens. So that's the main function here. And so basically, while that the source is not at the end, we're going to say this the start is this the current, and for each token, we're going to scan it. And then once we scan all of the tokens, we're going to push the end of file token at the very end and return this tokens. So you can see the main function here is this scan token. All right. So for each token we're going to scan, we're going to get one character at a time with this advance. And then because we use is at ends, we want to create that function as well. So what does that mean? If this basically if the current character we're iterating on is less than or equal to the or is less than equal to the source.length, then we're not at the end yet. So for scanning token, it's actually just a bunch of switch case statements here. So for each character we're advancing through, we're going to, if it matches one of these cases, we're going to add a token and then break through from that switch case, and that means we go to the next token. So what is advance here? Let's start advance. Basically, we're going to get the character at this current where we're currently at. We're going to increase this current so that for the next time we iterate through the source, it's going to be at the next character. But we're going to return the current character we're at. And if the current character matches one of these things, we're going to add that token. So if the current character is, let's say, the right parentheses or something, we're going to add the token type right parentheses. So we have these two functions here, add token and add token with literal. So here it's just using add token and it's only passing in the token type here. So we're not going to have any literal because these ones don't require it. And what that looks like is in this tokens, we're going to add a token class with this token type and whatever text it is. And text is basically just getting the substring of that. In this case, it's going to be either one of these if it matches. And then whatever the line is, and literal is null in this case. So that's the difference between lexeme and literal. Literal will always have something there. It'll be the raw text from the source. But lexeme is a bit different in that lexeme is basically the string of the token type. In this case, our token type is a right brace, and our lexeme is this character here. Now, once we have that add token function there. And then for our case, we do want a default option. Default meaning that if nothing matches, we're going to return an error, what's the error, whatever line we're in, and tell them that, oh, we have an unexpected character there. Just break. All right, so these are the single character ones. We're going to have one or two character lexemes that we want to match. So for example, if we have this bang operator, if the next token is a equal sign, then we're going to pass in bang.equal. But if the next token is not the equal sign, it's just a bang character. So that's why these are a bit special here. And let's look at the equals. Now, if the next character is also equals, we're going to pass in the token type equal equal. Otherwise, it's just one single equal, and it's going to be token type equal. Same with these greater and less than equals. Either they're less than equal, greater than equal, or they're just less or greater and greater. And we have this function called match. So let's see what this does here. Now, match looks at if we're at the end, then we'll return false because there's no match here. Otherwise, we're going to see if what we expect, for example, if let's say we're looking at double equals, then is the next character and also equals, or is it not an equals? If it's not equals, we return false. Otherwise, we return true and move the current up one number. Next, we're going to look at the forward slash. So if the next character is also forward slash, then that means we have a comment. And the comment will go until the end of a line. So that's what this is doing. We're going to keep on advancing through until we reach either the new line or it's the end of the file. So we're going to keep on consuming this. So for example, if we get this, we're going to keep on consuming this whole string because we don't really want to match comments. We're going to ignore comments here. But if we only have a single slash, then we're going to add the token type slash and break from there. And we see that we have this dot peak. So what is peak doing here? Peak, again, we're going to check if it's at the end, then return that. But we're going to return the character at the next position. So that's what peak is doing. So for example, if we have if we pass in this slot here, we're going to peek to see if the next position is a new line or not. That's all it's doing here. Looking at the next spot of our source. Some more things we're going to match on. New lines, tabs, whatever, we're going to ignore all those. We're going to ignore all these, and then we're just going, and then if we see a new line, actually, we're going to increase our line count by 1 and then break from there. And finally, if we see a double quotations, we're going to call this dot string. And what this dot string does is here, if we have multi-line strings, we're going to just keep on advancing through them. And then if we hit the end without another quotation mark ending it, we're going to return error because it's unterminated string. Otherwise, we're going to consume that closing quotation mark. And then we're going to grab everything in that surrounding quotes using this dot substring. And we're going to add the token with the literal. So for example, if we passed in something like hello world, the first quotation will be matched here, and it's called this string. All right. So it's going to match there. And then the next character will be hello. And because this dot peak is not the end quotation and it's not the end, it's going to keep advancing through that string. So we're going to keep on advancing through that string until we reach the end quotation there. So this while loop is going to exit because we have the end quotation. And then we're going to advance and consume that final quotation there. And then we're going to get that value using this source.substring. So our value, and we're going to do this start plus one, this current minus one. That basically just trims the surrounding quotes. And we're going to be left with hello world as our value, and that's the token we're adding, token type.string and the value. Next up, we're going to find if anything is a number. So if it is a number, we're going to keep on advancing through the number until it's not a number. We're also going to handle some fractional parts. So if we see a period and the next digit, next character after is a digit, we're going to consume that period and then keep on advancing past that. So what this looks like here is, let's say we pass in the number 1, 2, 3, 4, 5. So first one's a number, that's fine. And then it's going to, and then as long as the next ones are all numbers, we're going to keep on advancing through that. So 1, 2, 3, 4, 5, keep on advancing until, let's say, we hit semicolon and it's not a number. It's going to break out of this. And then it's going to add the token with the token type number. And it's also going to parse the float. And we're going to get the number using this source.substring. And this also handles fractions pretty well. So if we have that, this if statement here will also be able to handle that fraction. So that's how we handle numbers. Now, what about alphabet characters? So if we see anything that matches is alpha, so alphabet will be anything between A to Z, either lowercase or uppercase or an underscore. If it matches any of that, so here, if this alpha matches, we're going to call this identifier. And this identifier basically let's go back to that again. So this it checks if anything is alphanumeric. So if it's either a character or if it's a digit. And digit is, so because these are strings, right? We can still use JavaScript's method of checking if it's digit, if it's between 0 and 9 string formats of these. That's a clever little hack. All right. So if it's an alphanumeric, we're going to keep on advancing. And same as before, once we advance through it, we're going to get a substring. And then we're going to check if it matches any keyword. If it matches a keyword, we're going to pass in that token type. Otherwise, if it doesn't match a keyword, it's a token type identifier. And we're going to add that token. So now we have to get this like keywords. And if you recall, all our keywords were identified in token type here. But we just want to match it with that particular token type if we get that in the string. So let's take another example again. So let's say we get var hello. So if our first string here is var, and the text the text will match var, we're actually going to get the token type .var instead of saying, so this is not a string, but this is a token type .var, and that's how this identifier will work because that text will match one of the keyword's keys. And our type will be token type var. All right, so we pass in, so let's say we pass in token type var. And next up we have hello. Now this is another string. We're going to keep on consuming this. We're going to keep on advancing until we get hello. Our text is hello. Now, we don't have any matches in this keywords. So then that means that hello is going to have a type of null. And if that's the case, that's going to be token type identifier, which makes sense because this hello is not a keyword. It's a identifier. It's something that holds our variables. And then we're going to add that token type. All right, so that's our scanner class. Now we just need one more file, main.js. Main.js will just import logs from Lox.js. And then we're just going to call logs.main. And with that, we have our scanner. So let's try that out. There we go. We typed in 5. We get the number 5, Lexing 5. Let's try to instantiate. Oh, let's try string first. Perfect. It finds out this hello world is our whole string. We have a semicolon here. And let's instantiate the variable here. So defines that the first token is var, and then this variable is not string, but it's actually an ID, and that's why it has no literal, and defines that equal sign, and then finds that the string of OK, semicolon, and a file. All right, so that's it for our scanner class. Next time, we're going to look at building an abstract syntax tree. Please subscribe if you like this and want to keep notified of future videos. Thank you.